So now we're ready to begin the lab. First we'll talk about the requirements and we'll review your VPC setup. We'll learn how to load the configuration onto the Juniper SRX. We'll do some testing and troubleshooting of connectivity and different failover scenarios and talk about real-world performance considerations. Now the first step is to log into our AWS dashboard. So go ahead and connect to the URL there and use the username and password provided. When we get into the dashboard, you can see we've set up 5 VPCs in this region. Amazon currently limits you to 5 VPCs per region. So for students 2 through 10, we have this set up on an additional region, Northern California. Okay. Presuming I'm student 1 here, you can see that I have a VPC defined. I have a VPC CIDR address defined as 172.16.1, right? And that's associated with my VPC domain. If we look at some of the other options for the VPC, you can see I have a route table associated with each VPC here. And this is where routing information gets propagated between your VPC and the virtual gateway. Here I've added 2 routes. One is a default route to the virtual gateway, and another is a specific route for our subnet. By adding the default route, I'm allowing the internet traffic to flow back across the VPN and out your SRX internet connection. Clicking around in here, you can see this is where we define the customer gateways, and I've already preset these up for a lab environment with your public IP address. If we were to create a new gateway, you can see it gives us the option of putting routing as either dynamic or static. In most cases, you'll have static routing, but if you do have a BGP, dual BGP service provider, then you go ahead and put the AS number in there. Since these have all been pre-populated, we can click on and check out the virtual private gateways we've defined. As you can see, I've done one for each student, and I've attached the gateway to the VPC. This is essentially just a binding between the gateway where you attach it to the VPC. You can see these have already been attached. Okay. As you see, we've also created the 5 VPN connections for each of your gateways. This was the final step, in which actually allows us to download the configurations for our SRX. So you can see here, if I'm student 1, when I'm ready to configure my device, I simply click the Download Configuration button. And it prompts me to select the vendor of my device. As you can see here, Juniper Networks is listed. And we select the J-Series routers running GNOS 9.5. The J-Series routers is the legacy platform to the SRX, so this has been supported by many years from Juniper, running on the same code base. When we click Yes Download, it'll download the configuration to our PC, and we can open it up and take a look. Okay, I'm going to flip back and forth between the slides. So essentially the steps we went through is we went through creating a customer gateway where we put in the public IP address, right? We have created the VPN connection where we selected dynamic routing or BGP, and we associated that with our customer gateway. Now, BGP sounds scary to some people, okay? Makes you think that you need to hire a BGP expert just to configure this, but that's not really the case. BGP is the ideal method for load balancing and failover, both by Juniper and Amazon Web Services. On the Juniper platforms, a BGP license is not required. Some vendors, they'll charge you extra for that. On top of that, all the BGP configuration and filters are provided by AWS, so there's no BGP traffic engineering or engineer required. As you can see, it'll be a simple copy and paste exercise. All right. I showed you this step earlier where we had to associate the routes with our VPC domain. So those have all been pre-set up for you. And you saw we downloaded the configuration. If we take a look at this configuration file briefly, we can see that Amazon spits out a full configuration of set commands that we can just load onto our device. There's many comments in here, and there's some identifiers like your VPC connection ID, right? And in some scenarios, you may wish to change some of these values. For example, we may want to turn on trace options. We simply uncomment these lines out of the config file. You can see also that throughout the config file, we have the external interface defined. It's currently set to GEOOO. That will work for our lab environment, but if you use a different interface for your public IP address, you may need to change this. Amazon configures the tunnel interface in a zone called trust. If you wish to use another zone name other than trust, such as VPN or AWS, simply change the zone name here to put the tunnel interface in the right zone. You can see here that they set the TCP MSS to avoid fragmentation across the tunnel, 1387. And the BGP export policies are defined automatically to export the default route into the cloud and reject all other routes. You may wish to change this if you have an IGW in your VPC domain, or if you're not routing the internet traffic back. We like to use route filters with exact matches so that we can maintain control of exactly which routes are going to pass between the two systems. Okay. So now that we have this config file, it's simply a copy and paste exercise. We'll go ahead and SSH to our device. We'll use the VI text editor to paste the entire config file in, and we can go ahead and make sure that it looks right. So we'll go through that exercise now. First, I'm going to connect to my virtual SRX instance. You can see your password's been provided on the student handout sheet, BCT Lab 64. Now from the CLI here, you can see I can VI the file, right? And I simply paste the contents in there, and I save the text file with this command. All right. Now we enter CLI to enter the GNOS config. We go into edit mode. Just getting in the next slide. So we're simply going to load the set commands that are provided by Amazon by using the load set command. You'll notice that there's a bunch of warnings spit out. These are simply the comments within our text file, and they can be safely ignored. If we're to do the show compare at this point to see what commit changes are going to be made with this new configuration, we'll see the entire Amazon config has been pasted in here, including the IKE gateway, the IPsec VPN, the security tunnel interfaces with the IP addresses, the BGP config. The only thing not included in here is any security policies, but in this lab environment, since we're putting the VPC in the trust zone, those aren't required. So I'll go ahead and commit my changes here. Now a commit in GNOS will actually apply the changes, and we can always roll back if required. Great, now the commit's successful. Now the first step we're going to do is check the status of the IKE and IPsec connections. We'll run a number of show commands here. You can go ahead and exit the config mode and do a show security IKE security associations. That'll show our two IKE tunnels to Amazon, to the two different VGWs. We could go ahead and do a show security IPsec security associations, and you see our phase 2 IPsec SAs, one in each direction, built to and from the two different Amazon gateways. Another command I like to use is show interface terse match ST, and that'll show all of our VPN tunnel interfaces, complete with the IP addresses, and their status of up indicates that the phase 2 has been successful and the VPN's established. All right. Moving forward, we could check this. Now that the tunnels are up, we can check the status of BGP. I'll just do a show BGP summary here, and you'll see we have our two BGP neighbors, right? It'll tell you the number of routes that have been exchanged here and the lifetime. Now, in order to show which routes we're actually advertising and receiving, you can use these commands. Show route advertising protocol BGP with your neighbor address. Just pick one of your neighbor addresses, right? You can see that we're going to be advertising the default route over to Amazon. And you can also see which routes you receive from BGP by using show route receive protocol. And you can see that we get a 172.16.1 address. Based on your student number, you'll have various 172.16 networks received. So this shows me that routing and IPsec has been successfully established to Amazon. I can get more information on the particular route by doing a show route detail. All right. You can see I have two paths to this network, one through each of my BGP peers on the tunnel interfaces, and the current active route is pointing to STO.2. You can see that by the asterisk. Now, the two routes are built for redundancy, so if we were to disable one of the tunnel interfaces at this point, I could disable STO.2, and we'll see the route flap over, and this route will become active. To do that, I'll go ahead and enter edit mode, and I'll do a set interface STO disable, and we'll do a commit. This is going to simulate a failure of one of the VPNs, just like it would be if there was an intermittent issue on the internet or on the Amazon side. So if I check my route again, you can see that now there's only one path to that destination through STO.1. Right, so BGP has detected the failure through the IPsec heartbeat and deactivated the route automatically. So this provides a very fast and efficient failover mechanism when Amazon's doing maintenance or there may be problems across the internet. We could go ahead and roll back our config at this point. So that I'll activate our tunnel interface again. Now Amazon does a really good job of spitting out the configuration, but it doesn't spit out any security policies. So in this example, we have the tunnel interfaces are defined in the trusted zone, same trusted zone as our user traffic comes from. And we have a default permit all policy there that essentially lets anybody talk to anybody on any application. So this is the policy we're going with for the lab, but in the real world, you may want to enforce more specific policies to and from your Amazon cloud. To do that, you can also use the JWeb interface. Juniper provides a nice web interface on the firewall where you can easily configure your security policies here under security policies. We'll see that this is our default policy here from trust to trust. If you wanted to edit that and exclude certain networks or applications, we can do so. And for the purposes of this lab, we'll leave the connection open. All right, the next step is to connect to our AWS instance. Now, in this case, we have an Ubuntu instance running behind our VPC, and Amazon gives us a public key file which we use to connect. Right? The public key files are all downloadable from the files you downloaded at the beginning of class. So we will use the command to connect to the cloud, SSH-I with a student key that we provided, and then Ubuntu at your VPC host. If you had questions about which VPC host you're assigned, the one pager that we distributed with the class has all the IP addressing information. So now here we are connected to our VPC host over the internet using our VPN connection. You can see it's a Linux host here. I can ping out to the internet through this host, but of course the traffic's coming back across our VPN and routing out our local internet connection. I can also connect from the VPC host back into my PC itself. If I look at my IP address real quick. Right. So since we have this direct IP connectivity between locations, I can also run other protocols like SFTP, and we could do some file exchanges. So you may wish to SSH back to your SRX device, where you can then download some files and get an idea of the performance that you're going to get across this tunnel. Now here in our lab environment, we're sharing the internet connection with 30 other people in the office, hard at work right now. Of course, the bandwidth is shared in this scenario, so our file transfer speeds are dependent on the available bandwidth of the network. All right. Of course, if you have a QoS set up and you want to give priority to your Amazon traffic over all the other traffic, that's certainly possible as well. We'll talk about that a little later. Of course, before you can connect to your VPC machine, you need to make sure that you have a route to your VPC network. So if you're trying this from your local PC, you may need to add the route add command, such as this, where you're routing your VPC network, replace the X with your student number to your local PC. And if it's the first time you're using this SSH key file, you may need to do a chmod 400 to change the permissions on it. Otherwise, SSH gives you a warning about connecting. But there we have it. We're all connected to the VPC VPN. And wow, that was pretty easy. If you like this training and you like some additional material on other solutions, we've listed a number of URLs here. They're also available in the printout. There's some guides from Amazon and from Juniper that'll cover these solutions in more in-depth and detail. Thank you for coming, and we hope you enjoy the training.